Now I'm going to go over classwork 23. I kept updating the checklist just just to give you the 100% experience with kinematics, so that if you ever have having conversation with like NASA engineer or a SpaceX engineer regarding sending a rocket to the Mars, then you'd be able to understand the conversation. Okay, so we are talking about instantaneous velocity is not equal to average velocity. How can we prove that? Okay, instantaneous velocity is not equal to average velocity. Okay, so consider this problem. Mr. Bari went on to, let me see, it is working. Yeah, went on to 1.5 hour long car trip, and his position function is 40/3 t square at 1.2 hour. These are speed limit sign. At 30 miles per hour. And at that time, the cop pulled him over, and we try to understand that did he get the ticket? Did he break the law? So before 1.2 hour, there is no way cop can stop him. Why? Because there is no rule. If there is no rule, you cannot break the rule if there is no rule. Okay, so now we're gonna do dt graph, vt graph, at graph. So dt, vt, and at. Okay, so dt, vt, and at. How can we draw the dt graph? We need 2 points. We have 1 point 0, 0. The other point we have 1.5 comma what? Vt we have 0, 0, of course, and the other point is 1.5 comma what? At we have, of course, the 0, 0, and the other one 1.5 comma what? Okay, so it seems like we just missing only one variable for each graph. Quickly find that. It's not that difficult. So dt is equal to 40/3 t square. So dt is 3/2, which is 1.5, 40/3, 9/4. So this is 40. Okay, so this is, oh no, not this is 40. How much? 30, I guess. 3, 10, 30. Okay, so 30. Okay, all right. So this is quadratic because we know that this is quadratic. This is 30. Okay, so this is 1.5 comma at 1.5 hour. How much distance did he travel? 30 miles. Okay, this one we're gonna do a different color. Vf is equal to Vi. Not we cannot use that one. So 1.5, right? So we want to know the velocity v. Okay, so what do we know about this? Area is equal to half pH. So area is how much? Area is 30. At what time the area is 30? At 1.5 hour the area is 30. Don't forget the half, and h is the velocity. So velocity is 40. So this one is in fact 40. Okay, so this is 40. Okay, great. Great. If this is horizontal, this is if this is diagonal, this has to be horizontal. This is 1.5. So area is what? Let's use blue. Area is BH. Okay, so area is what? Area is velocity. B is what? Time. H is what? Acceleration. Velocity is how much? 40. Time is how much? 3/2. So A is 80/3. Okay, good. Now we should be able to write those equations. The equations for this line is P of t is equal to 40/3 t squared. The equation for this line is, now we can write it, 80/3 t, and the equation for this line is 80/3. Okay, great. We have everything so far. Now I'm gonna give you three more graph. So graph 1, graph 2, and graph 3. The graph 1 I'm going to put over here, and this is your dt, this is also your dt, this is your vt, dt and dt. Okay, let's if this is this one, this must be also this one, and this must be, if this is curved, this is diagonal. Okay, we know the point, but that's not important. What important is, for this one we're going to use, okay, let's write three equations for this. Equation number 1, for this we're going to use, let's put the point, point here, point here, point here, point here, okay, and point here. This is 1.2. Okay, all right, what does that mean? This is the slope, this is also the slope, and this is the midpoint. Okay, so for this one the equation would be, bf is equal to vi plus at. For this one it should be velocity average is delta d over delta t. For this one, average velocity is vf plus vi over 2. Okay, so bf is equal to, what is bi? Is 0. How do you know? Okay, so Mr. Bari went on to so from rest 0. A is 80 over 3, 1.2. So final velocity is 32. So at 1.2, what is the slope of this tangent line? Okay, it's 32. Okay, all right, and then this one. Okay, so here is 0. So v is df minus di over tf minus ti. All right, so we know that this is 1.5 and this is 30. We know that this is 1.5 and this is 40. How do you know? We already found that out. So df is 30 minus 0 and 3 over 2 minus 0. So v is equal to 20. What is the slope of this one? 20. Okay, so v is equal to, vf is 40 plus 0 divided by 2. So whereas velocity is 20. So what did you discover? You discover exactly what you wanted to discover. Average velocity is 20, which is not equal to 32. Why? Because 20 is smaller than 32. Okay, good. So you discover that average velocity is not equal to instantaneous velocity. Not a big surprise, not the biggest surprise in the world. Now you're gonna get to the biggest surprise in the world, because I'm gonna change something, and that's gonna probably give you aha moment. And that is, if I say that average velocity is equal to instantaneous velocity, what do you have to do? Okay, and that's going to take you to the next problem.